Welcome to this explainer, where we're going to unpack a massive, fundamental shift in how we build frontier AI. For a long time, the dominant strategy in artificial intelligence has been to build massive systems, pump them completely full of data and energy, and essentially just cross our fingers. Imagine trying to build a bridge by just dumping thousands of tons of concrete and steel into a river and hoping that eventually an arch forms. That is basically what we've been doing with AI. But we're finally moving from hoping for magic to demanding rigorous engineering. And today, we're going to look at exactly how that transition is happening.
So that brings us to a really huge question. Do we just have to sit back and wait for AI to hit some magical threshold where it suddenly gets smart, or can we deliberately architect that intelligence ourselves? Today, we're analyzing a paradigm shift that takes emergence from a probabilistic waiting game into a deliberate engineered discipline. Right now, engineers feed mountains of data and compute into a model and basically wait to see if it learns reasoning, math, or coding by sheer chance. We're just hoping those capabilities appear out of the noise. But what if we didn't have to wait? Our core focus in today's explainer is breaking down the exact structural mechanisms that make this control possible, specifically the trigger mechanism, directionality, stability, efficiency, and control. Think about phase transition engineering like freezing water, right? We aren't just hoping it eventually gets cold enough to turn into ice, we're engineering the exact moment and conditions for that transition to occur. We're going to prove that this kind of phase transition engineering in AI isn't just some speculative future promise. It's something that the energetic paradigm, or EP for short, actually achieves right now, at the framework level.
To do that, we're going to follow a really specific path today. Think of this agenda as 5 dials on an engineering dashboard that we need to check. 1. The emergence illusion. 2. Trigger and target direction. 3. Stability meets efficiency. 4. Making risk interpretable. And 5. Engineering emergence today. Let's just jump right into that first dial.
Section 1. The emergence illusion, moving from probability to design. Let's start with this pervasive illusion in the AI space that we just have to blindly pump energy and compute into models until capabilities miraculously appear out of the noise. Think about the sheer amount of compute we're talking about here. Pouring billions of dollars of energy into a model just to see if it randomly learns logic. It's kind of like trying to light a candle with a flamethrower. It's wildly inefficient, and it relies entirely on sheer force rather than precise design.
And this is the crucial point. Honestly, it's the anchor for our entire explainer today. Bigger models wait for emergence. EP already engineers it. While traditional scaling waits for emergence to happen probabilistically, the energetic paradigm deliberately engineers it by changing the structural conditions. It actively forces conditions like coherence, path discipline, and stability under perturbation. What does all that actually mean in plain English? Well, path discipline means setting strict structural guardrails so the AI doesn't hallucinate down some random rabbit hole. Stability under perturbation just means the system doesn't completely break down the second it gets confused by a weird prompt. It's literally the difference between doing a rain dance and building a precise irrigation system.
Section 2. Trigger and target direction, the first 2 dashboard dials. Let's look at how this structural emergence actually gets sparked in the first place and where it goes once it starts moving. So, looking at that first dial, the trigger, there's a massive separation between these two philosophies. Traditional scaling relies purely on magnitude. Effective compute just crosses a brute force threshold, and we cross our fingers that the capability changes. It's kind of like trying to force 1,000 puzzle pieces together by hitting them with a hammer. EP, on the other hand, is triggered by structural coherence. The system is designed to cross a specific coherence boundary, creating a beautifully stable new organization. You aren't just pushing harder, you're actually designing the puzzle pieces so they magnetically snap into perfect alignment the moment they get close.
Which brings us to dial number 2. Directionality. In scaling, direction is totally uncertain. The system wildly explores a vast space, and we only figure out what it learned after the fact. It's exactly like dropping an explorer in a pitch-black infinite maze and just hoping they stumble on a treasure chest. But EP? EP specifies its target in advance. It gives the explorer a map and a compass pointing directly to the treasure. By tweaking structural variables, like strengthening hierarchical compression for instance, EP specifically targets abstraction and reasoning. The actual destination is programmed right into the architecture from day one.
Moving to Section 3. Stability meets efficiency, sustaining the system under pressure. Because it's one thing to build an incredibly smart AI. It's an entirely different thing to keep it from collapsing when the messy, unpredictable real world actually tests it. Let's see what happens to these systems under pressure. The stability dial shows us a really stark contrast. Scaling-based emergence behaves like a high-pressure state. It absolutely needs massive, sustained energy to stay intact. The moment resources fluctuate, the system's performance degrades. Think of it like a hot air balloon. The very second the fuel stops burning, it's crashing back to Earth. EP, however, builds what's known as attractor stability. Its capability is supported by its underlying geometry, not just continuous brute force. It's much more like a geodesic dome. It stays up effortlessly because the architecture itself distributes the weight. It's just structurally sound by its very nature.
And naturally, that leads us right into the efficiency dial. Scaling inevitably hits a wall of diminishing returns. Pouring more and more energy into the system buys you smaller and smaller marginal improvements until you somehow cross another massive threshold. EP structurally multiplies its effective energy usage. By increasing path efficiency and coherence, it gets vastly more output for the exact same energy it consumes. Why does this matter for us? Because it could literally mean the difference between an AI that requires a small nuclear reactor to generate an answer versus an AI that can run efficiently on your laptop, simply because every single watt of power is structurally optimized.
Section 4. Making risk interpretable. The final dashboard dial. And this addresses the massive elephant in the room when it comes to frontier AI, unpredictable behavior, and what actually happens when the machine gets it wrong.
Scaling produces uncertain and probabilistic risk. Because the system's capabilities are discovered totally by accident, its failures are deeply surprising. If a scaling AI fails, it acts like a complete black box. We have absolutely no idea why it hallucinated, because we didn't design how it learned in the first place. EP completely flips this. Now, EP emergence can still fail, for sure, but that risk becomes geometrically interpretable. Think of it like a carefully engineered circuit board. If something goes wrong, we don't have to guess. We can trace the exact wire or structural assumption that shorted out. That traceability makes the next generation of AI vastly safer.
Section 5. Engineering emergence today, the paradigm shift realized. Okay, let's pull all these threads together. Let's see how all these dials we've just been looking at build into a cohesive, highly functional reality right now.
When you step back and look at the whole dashboard across these 5 dimensions, trigger, direction, stability, efficiency, and risk, the contrast is literally night and day. We're trading the absolute chaos of accidental discovery and high-pressure brute force for the precision of robust geometry and traceable multiplied efficiency. We've successfully turned what used to be a probabilistic weighting game into a rigorous engineering discipline. All 5 of these dimensions are no longer mysteries. They are actual, controllable design variables that we can tweak. And we have to keep coming back to this one defining truth. Bigger models wait for emergence. EP already engineers it. It is so absolutely crucial to grasp that the energetic paradigm is not pitching this as some speculative, sci-fi future promise. No way. It is actively achieving this structural phase transition at the framework level today. This isn't science fiction. This is applied engineering in the real world. Now, just to be perfectly objective here, let's set up a quick guardrail. The claim being made is not that EP has magically solved every single frontier-scale AI problem overnight. That's not it. The precise claim is that EP already achieves this structural mechanism conceptually, demonstratively, and experimentally at the levels we've just mapped out together. It's providing the critical architectural foundation, which really is the necessary first step to solving those massive, broader challenges. And honestly, that foundational piece is what matters most. By structurally engineering these exact conditions, EP makes true emergence achievable, stable, and testable. It basically takes the blindfolds off for us. We no longer have to be terrified of the chaos of unchecked, unpredictable AI growth. Instead, we have the actual structural blueprints to build AI safely and intentionally, bridging that huge gap between wild probability and deliberately designed intelligence. Which leaves us with a really exciting final thought to ponder. If the probabilistic weighting game is finally over, if we actually hold the literal blueprints to architect intelligence through structural engineering, what capability are we going to choose to build first? Thanks for joining me on this explainer. I really hope this helped bring a massive shift in AI architecture into crystal clear focus for you today.